Okay, so how do we solve systems using these augmented matrices? And so what we're going to do is we're going to perform these row operations, which I'll talk about in a second. But we want to reduce this side, the left side, to the identity matrix. And when we do that, what's going to happen is we're going to get some number here and some number here, and those are going to be our solutions. And so if you notice, this is where the x and the y would be, and so that would end up being just an x is equal to whatever this number is and just a y equal to whatever that number is. So we're going to hop into what's a row operation. Okay? So these are legit, man. These are things that you can do that we can work with to solve these problems. We can switch any two rows. So for example, if I had 2x plus 3y is equal to 5 and 4x plus 2y is equal to 6, could I flip-flop these? Absolutely. We can do that. Okay? We can add one row to another. So that means I can take two rows and add them together. I'm not going to write that. We'll talk about it as I go through it. I can multiply any row by a constant other than 0. Okay? And I can put all these different operations together as long as I'm following order of operations. Okay, so these are all the little things that we can do to manipulate these problems. Okay, so on to the notation. So this notation means I'm interchanging two rows. Okay, this notation right here says I'm going to multiply each entry in row 3 by -2. Okay, I'm taking each entry in row 3 and I'm performing a scalar product, -2, and then whatever I get from this is going to go over row 3. So that means, let's say row 3 was equal to 1, 2, 3. What I'm telling you to do is to take -2 and perform a scalar product, and that is going to change it to -2, -4, -6. This is my new row 3. Okay, and that would be using the row operations. So this one is the same thing, but a little bit more to it. I'm going to take row 2 and multiply it by 4, add it with the guys that I got in row 1, and that's going to become my new row 1. Okay? This might look a little bit overwhelming now, but we're going to go ahead and hop into a quick example so we can practice this in the same video. Okay, sorry if this runs a little long. Okay, so here's our matrix, matrix A. And A and B, here are the answers. Okay, I should actually white these out, but that's fine. So we know that this is what the answer is going to be. And this is what the answer is going to be here. So actually, why don't you guys do this? Based on what you just saw, why don't you go ahead and try and get these solutions with the instruction that's on here. Right here, our instruction for A is to do this, and instruction for part B is to do this. Pause the video, do the work, and then watch how I do it. Okay. There's the bell. Love it. Okay, so anyway, what I've done here is I've written this all out, and you don't necessarily have to write it all out. So this guy right here, this is the bar to separate the coefficients from the constants, okay? And I'm going to go ahead and I'm going to take 4 times row 1. So I have 4 times row 1, and I'm going to add row 3. So that's the instruction, and that's going to replace row 2. Okay, just some basic row operations. And so I'm going to go through and I'm going to multiply it through. I get 4, 16, 12, and 3. This should actually be, I can't erase that. Hold on one second. This should be 12, not 3. Sorry about this. There we go. So that's 12. And then I'm going to add that with 7, 3, 8, and 2. And I'm just going to add corresponding pieces. 4 and 7 is 11. 16 and 3 is 19. 12 and 8 is 20. I got my little separator right here. And 12 and 2 is 14. And this is my new row 2. Okay? So now, let's do the same for B. And, hey, another bell. All right. So now I'm going to go ahead and I'm going to take -2 times row 3, and I'm going to actually just do this in my head because this is pretty simple math. Here's row 3. So what I might do is I might just write down row 3, and I'm going to go ahead and I'm going to multiply this by -2. So that gives me a -14, a -6, a -16. I'm running out of room here. And then I'm going to get a -4. And then I want... Okay, so this piece right here was -2 times row 3. And now I'm going to take 3 times row 1, and I'm adding these guys together. So 3 times row 1, so that's going to be this, oops, that's this row. So 3 times 1 is 3. 3 times 4 is 12. 3 times 3 is 9. And 3 times 3 is 9 again right here. And so now I'm just going to add these guys together, and this is going to be my new row 1. Okay, so now -14 and 3 is 11. -6 and 12 is 6. And I'm just adding these guys together. I'm doing it vertically. This is going to give me a -7, and this is going to give me a 5. Okay, and these are the basic skills when we're doing row operations that are going to allow us to solve these systems.